let's talk about the tangent ratio. So this is the last one of our trigonometric ratios for right angle triangles. And it's for the last pairing of sides. We've done adjacent and hypotenuse, we've done opposite and hypotenuse. So this is the last pairing that we can do. It is tangent, written as tan of theta. Remember that that is just some angle, any angle, just like we'd use x for. And that equals the opposite over adjacent. Okay, so looking at a triangle here, we know that this is our right angle, and we'll say that this is our theta, that is our angle. If that is true, then if we look all the way across, imagine this is an eyeball and shooting all the way across, that is going to be our opposite side. And then the side that touches the angle but is not the hypotenuse, so this would be the hypotenuse because it's across from the right angle, which means this side touches the angle but is not the hypotenuse, so that would make this the adjacent side. Okay, so there's opposite and adjacent on this triangle. Now, tangent is a little bit of a special case, and this is a little bit of an extension, so this isn't necessarily part of just trigonometry, but just so you know. So if you look at this triangle, imagine this was like a ramp going upwards. You could say that the opposite was the same as, say, a rise, right? Because it's going up, rising up. Okay, and then the horizontal here, the adjacent side, you could say that's like a run, right? It's running to the side. Okay, which means that tangent of theta is also rise over run, which is actually the slope. Right, so the slope on a line is also its tangent of the angle. How cool is that? We can use that a lot. That's an applied question. We'll look at that a little bit later, maybe in a different unit, but just some cool things for us to know. But we're going to figure out this bit first. We're going to look at solving both of these sides and then look at solving for the angle. So let's take a look here on a new blank page. So let's say we had some triangle that looks a little bit like this, right? We're going to stick our right angle in the corner here. We're going to stick our angle down here, say 65 degrees. And then we've got a side length of 13 over here and an x up here. And then I'll just close that triangle there. Okay, so we know this is going to be tangent, but let's take a look anyway. So looking at the angle and all the way across, that's going to be our opposite. Okay, and then looking at these sides, we know that this side is going to be our hypotenuse, which means that the last side here must be the adjacent. Okay, so we have opposite and adjacent, so that gives us tangent. So tangent of theta equals the opposite over the adjacent. Okay, so then tangent of theta equals, oh, pardon me, not theta. We know theta. We don't need to write theta. We can write 65 degrees. Right, because we're filling in the things that we know, so we know that 65 degrees is our angle, so we fill that in there. Then we've got our opposite that we can fill in here. So that's x over our adjacent, which was 13. Okay, so we want to get x on its own here. We've got to get rid of that divided by 13. So to get rid of something in math, we have to do its opposite, which means instead of divide, we're going to do times, and we're going to multiply by the thing we want to get rid of, so 13. Okay, divided by 13 and times 13 cancel. And then we have to do the same thing to the other side to make it fair, because math is fair. Okay, so if I were to rewrite this just for clarity's sake, we'd end up with 13 times tangent of 65 degrees equals x. Okay, so now we can solve the left side since all of that is solvable over there. So we've got 13 times the tangent of 65, which is roughly 2.1445. Again, just keeping those 4 decimal places. Now tangent, you'll notice, is the one that can go above 1. It can be higher than 1 since it doesn't involve the hypotenuse, so there's no requirement for one, either the opposite or the adjacent, to be higher or lower than the other. Okay, so that equals our x. So if we multiply those together, 13 times 2.1445, we will get 27.9, which again, I'm rounding there, but that is our x. Okay, so that is to solve for the opposite side. you'll start to see a lot of similarities between all of the trigonometric functions. This does look a heck of a lot like what we did with cosine, and the next one's going to look a heck of a lot like we did with cosine and sine. It's repeated over and over because it is the same kind of ratio, right? It takes this form of the ratio and then two sides. So it's the same kind of math every time. It's just knowing which one to use. Okay, so this one we use for opposites and adjacents. So let's take another question that matters. So this is another triangle here. Let's say we have an angle of 55 degrees. We'll have an opposite side here over here at 16, and then this side at x. Okay, and then we'll stick our corner there. Okay, so we look across for the opposite, right? And then across from this right angle, we get our hypotenuse, and the last side is our adjacent. I'm starting to skim through these a little bit since we've covered these a lot in the other videos, but this labeling part is still an important step. Okay, so we have the opposite and the adjacent, or rather we have the opposite, we need the adjacent, so we'll use those. We'll use tangent. So the tangent of theta equals the opposite over the adjacent, and again I like to write this whole thing down every time so I don't get lost. Okay, then we start filling in our values. So tangent of 55 degrees equals the opposite side of 16 over the adjacent of x. Now this is another form where we have something on the left-hand side and then something on the bottom of the right-hand side that we want to get out on its own. So we're going to use our little switchy trick here. Okay, so we're going to switch these two values. Again, we went over how to do this mathematically in the sine video. So I'm just skimming through this here just as this is a shortcut that we can use. So it ends up being x equals 16 over the tangent of 55. Okay, so if you're not sure how that works or you're not comfortable with how that happened, go and watch the sine video where I go over it. Okay, so now let's take a look at the math here. So we can solve the entire right-hand side now. So we'll take our 16 divided by our tangent of 55, which will be 1.4281. Again, just keeping those 4 decimal places. Okay, and then we'll just do that math again. So x equals, and then we take our 16 divided by 1.4281, which will give us 11.2. And there's the answer there. So this one's a little longer, but only because we have to do a little bit of a weird step here. And then it's just the same thing right at the end. Right, and that shortcut makes it about the same length anyway, so long as we remember how to do it. So that's the opposite and the adjacent. So the last thing we can deal with is the angle. And I'll tell you, this is the easy one here since it works in the exact same way for every trig function, so long as we're using these Sohcahtoa and we're using right angle triangles. We'll talk about Sohcahtoa in a bit. Okay, so there's a right angle here. We're given 21 and 14 as our side lengths here. And we're given just a big old question mark for the angle because we have no idea. So let's take a look here. If we look at this angle, we look all the way across, that should be our opposite side. And if we look right beside but not to the hypotenuse, we will have the adjacent. Okay, so tangent of theta equals the opposite over the adjacent, which will give us tangent of theta. We don't know theta this time, so we leave it as is, equals the opposite over the adjacent. Okay, that'll give us the tangent of theta equals, and we take our 14 and divide it by 21, which will give us 0.6 repeating. Remember that little line up top just means that it goes 0.6666666 forever. On and on and on and on and on. But I don't want to write an infinite number of numbers, so that I'll just write it that way. Okay. But then if we take we have to take this tangent off. We have to get rid of it. So we have to do its opposite. So we have to use a little function called the inverse tangent. Right? And it might not look like that on your calculator. It might look like atan or arctan, but it's the same thing. Okay, so the inverse tangent and tangent cancel, and then because math is fair, we have to do the same thing to the other side. So that leaves us with theta on this side, and then we just use our inverse tangent on our 0.666666666, however many you want to type in there. I did 4, which will get us our 33.7 degrees. Okay, so really almost exactly the same as cosine or sine on this section. Right, the angles are always the same. There's only really 2 kinds of work you can do in the math to find the sides. And otherwise it's just finding out, which sides do we have, so which ratio can I use? And I'll do another video on that one, how we some examples of how we figure that part out. But for now, that is how to solve using tangent, the adjacent, the opposite, and the angle.